at the sum of geometric series. So again, the formula chart you'll get on the test has the formulas. So geometric, there can be a finite series or sequence, meaning that there's an upper limit. Okay, or there can be an infinite, meaning there is no limit, it goes on forever. Okay, so it's different formulas depending what type of sequence or series it is. And remember, for infinite, you can only find the sum if the ratio's absolute value is less than 1. Okay, if its R value is greater than 1, then you can't find the sum. The sum does not exist because it's a divergent series. It goes on forever to infinity or negative infinity. So here we go. These three formulas are what we're going to be looking at. And we need to make sure we remember the sigma notation. So I'm going to jot those formulas down here just next to the instructions so we have them. So we can use the first term times 1 minus r to the n over 1 minus r. So you would have to know the first term, the ratio, and the number of terms. Or we could use the first term minus the last term times r over 1 minus r. So in this one, we know the last term. This one, we don't know the last term, but we know the number of terms. And then let's see. So for 26, it says to find the sum of the first 7 terms. So that right there is n. Okay, we're adding 7 terms. And then we do not know the last term. Okay, so we are not going to be able to use this. We're going to have to use this formula where we know n. We know the first term, because that's written here as 80. And then we can find the common ratio. Remember, the common ratio, we're told these are geometric. So we don't need to be checking all of them. We just need to find what that r is. So remember, you take a term and divide by the previous term to get that ratio. So 32 over 80 is 0.4. That is our r. So that's what we're going to plug in here and here. So it gets plugged in 2 places. So this would be the sum of those 7 terms would be 80 times 1 minus 0.4 to the 7th power over 1 minus 0.4. You can do this all at once in the calculator. You can do this piece by piece. That is up to you how you prefer to do it in the calculator. But again, so that's 1 minus 0.4 to the 7th power and 1 minus 0.4.
Yeah, sorry.
Times the 80. So as a fraction, it would look like this. Pretty large values in the numerator and the denominator. Okay, or you could do a rounded decimal answer. Just depends on your answer choices, what they look like for a multiple choice question. Okay, so either one of those would be correct. Okay, so that's the exact sum, and this is the approximated decimal for it. All right, now on 27, we know the first term. The first term is given. Guys, I'm recording, so keep it down as y'all come in late, please. All right, so this is the first term. Okay, and then we do know the last term in this one. They tell us a sub n. Okay, so that's going to go here. So I'm going to be using this formula over here because I don't know the number of terms. I don't know n, and this one uses a sub n instead of n. And they tell us r. I don't have to find r. It's given. So that's going to get plugged in 2 places there in that formula. Okay, so the sum will be the first term minus and then it's the 360,448 times 8 all over 1 minus 8. Hey, guys, we are in a class right now. Just get your stuff and go. All right. So this is what we're plugging in here to find this one. So I'll show you all in the calculator. Quick reminder, when you want to get a fraction, you can do the alpha y equals to get it to come out to show the numerator and denominator. Okay, so it's the 11 minus, and then it's that 360,448 times 8. Okay, all in that in the numerator, and then in the denominator, it's just the 1 minus 8. Okay, so this one comes out to 411,000. Gentlemen, we are in a class. Get your things and go. All right, so that comes out to 411,939. Okay, so that uses both, that practice using both of the different geometric sum formulas for finite geometric series, knowing that there's either knowing the number of terms or knowing the last term. Okay, so we used one of each. Now, the 8 just gives us the sequence, but that ... indicates that it goes on in that fashion. So this tells us this one is infinite. And 29 does the same thing with the upper limit being infinity. So these two are infinite sums. Those two were finite. So the formula for the infinite sum was the first term over 1 minus r. But remember, we can only do this if the absolute value of r is less than 1. If the absolute value of r is greater than 1, the sum does not exist. So first we need to figure out what is r here. Okay, so you can do this in your calculator. You're taking a term divided by the previous term, so 4/5 divided by 2/5, and you can flip and multiply to do that by hand, or since you're using a calculator, you can just do it in the calculator. It doesn't really matter. So 4/5 divided by 2/5 is 2. Okay, so my r is 2. 2 is definitely not less than 1. It is greater than 1. So in this case, the sum does not exist. And the reason is because the absolute value of r is greater than 1. So we cannot find the infinite sum because these numbers just keep getting bigger and bigger and bigger. It's times 2, times 2, times 2. This is divergent. It goes to infinity. No limit. Okay, that's why the sum does not exist. Now for this one, it's in sigma notation or summation notation, which we can identify r, because remember it's a sub 1 times r to the n minus 1. So the r is the 0.6. 0.6 is less than 1, okay? So 0.6 is less than 1, so that means we can use this formula. So we're going to find the sum by doing the first term, which that shows up here. So that's the -2 times or over 1 minus r, which we said r was the 0.6. So in my formula, that's going to be -2 over 1 minus 0.6. And again, you can do it as fractions, you can do it as decimals, it doesn't really matter. So that's -2 divided by 0.4, which is -5. So we are able to find the infinite sum for that one. All right, so I'm going to stop that video there because that's the end of the third page, and you can check the other videos for the other questions that you haven't gone over yet or that you have questions on.